On today's episode of the Leukopak Lady, I will focus on an issue that turns out is much more politically charged than I ever realized. That is the inconsistency of starting material and how it impacts therapy manufacturing and treatment success. First of all, I understand why this is controversial, because admitting that this is a problem means that the status quo must change, and that is no small thing to do. However, it is essential to identify and solve problems like these in order to make the best therapies possible. And I'm not sure if it's a good or bad thing, but I'm not afraid to talk about these issues. In addition, I'm willing to offer up solutions and do everything in my power to make those solutions a reality. So for autologous CAR T therapies, there are manufacturing failures up to 25% of the time. This causes delays in patient treatment, or the patient can miss out on treatment altogether. The top reason cited for manufacturing failures is the quality of starting materials. Admittedly, it is difficult to standardize patient material, I get it, but not doing so will create inconsistencies in the patient responses. Starting material for allogeneic therapy manufacturing is also highly inconsistent, and this causes many failed manufacturing runs and poor performance in patients. Leukopak to leukopak variabilities can stem from differences in both the donor and the collected material, and these factors are what I'm going to walk through in great detail in the coming weeks. And although iPSC lines are much more consistent overall, they do not get a pass here, because differences in the quality between iPSC master cell banks have been reported. Solutions to this issue are not difficult to imagine, but it will take admitting to what the problem is and working together to achieve solutions. For more consistent patient material for autologous therapies, one solution being explored is to collect the material earlier in the patient's treatment regimen. For example, after diagnosis, but before any chemotherapy or lymphodepletion have occurred. For fresh, healthy donor material to be more consistent, the donors must be very well characterized and carefully chosen for collection. There are many tests that could be run here on the donors or the material. These include flow cytometry characterization, mitochondrial function tests, proliferation and killing assays, and laser force cytology. Using data from these types of tests paired with predictive AI modeling, only the donors with the highest chance of success in manufacturing should be chosen for the collection. For more consistent iPSC lines, the donors and the material used for cell line generation should be put through the same rigorous testing and selection as the fresh, healthy donor material, plus testing of the generated lines to choose only the highest performing ones for use in therapy manufacturing. So, consistency in starting material is achievable, but it must be a major focus of the cell and gene therapy industry to make these therapies successful for patients in the long term. Next week, come back. I will discuss the differences in donor cell makeup and how to overcome those differences, and then I give a suggestion of a simple way to start creating more consistent leukopaks immediately. See you then.